muted on YouTube.
We can do that just as an experiment.
Madam is live now.
Mm.
Yes, I got it.
Do that just as an experiment.
Madam is live now. So good afternoon everyone. We are here after a long event. Everybody participated in Jigyasa 2020, which is our exhibition event. Like every year, we make it happen this year also, and it went smoothly in an online new format. Our participants are with us, and rest of you are watching it online live through this video feed. I would request Veda ma'am to keep your uh, microphone off unless needed. Let's go ahead. I would first invite Professor Jyoti Singh to welcome everyone who is watching this event either through Google Meet or live on YouTube. Jyoti ma'am.
Yeah, thank you, Rajesh sir. Professor Jangu Mistry, our own professor, he was in physics department for many years as a student and then as a professor and finally the head of the department, and he retired also many years ago, but he continues to keep in touch with the department and very active in physics also. So Professor Mistry, who has also been the judge of this exhibition, my department colleagues, and all my dear students, those who have come for this Google Meet, as well as all the rest of the students who have joined us live. First of all, a very warm welcome to you all. We could not accommodate everybody on the Google Meet, but of course, technology has come to our rescue, and so everybody else is watching this on YouTube, which is a great way of making everyone participate. So we are very happy about that. Allow me to take a few minutes to sort of give a historical perspective for this exhibition, because the students who have recently joined may not be aware of this tradition. So physics department has been holding exhibitions on various occasions for many years since the past. But about 12-13 years ago, we decided that we will have an exhibition where some TY and SY students would volunteer to put up an exhibition to introduce the incoming FY students to the physics lab and the possibilities of experimentation that the lab has. After a few years, some 3-4 years, the college got autonomy, and that brought in a lot of academic freedom to us. And as a result, this exhibition, which was already an annual feature, changed its format. And it underwent many changes, but the most prominent one eventually was that we started giving a theme, an interesting theme, so that all students have to put up an exhibit along the theme, and that made the exhibition very interesting. And then the last thing that changed that we did was that we made it mandatory for all the students of SY and TY. We were afraid that making something compulsory or mandatory, it has a sort of a negative connotation and may not be such a great idea. But actually, it turned out to be a great move, and all students over the years have always enjoyed putting up exhibits in this exhibition. And the day when the exhibition is actually live in our college hall, and all the fun of being there together and introducing your exhibit to all the people who visit to see the exhibition. Most largest audience is of course the FY students, but then we invite some outside schools, some other college students, and our own college students of other subjects and other faculties, even art students, arts faculties, everybody visits this. This year has been a very difficult year. We had the pandemic, and then we decided to have online teaching. So we started with online lectures, and by now we have learned our ways of giving online lectures fairly well. We manage it now. But then came the problem of how to handle practicals, because practical is an area where you really need to be physically present in the lab. Then, of course, we overcame that challenge also by thinking of various different ways in which online techniques that have developed over the last several decades can be used. So, we started using some virtual labs, numerical simulations. We gave students data from some publicly known good scientific experiments to analyze numerically using computers, and so on. We started slowly managing that also, and then came this big question of how to hold an exhibition this year, because exhibition was a very physical activity, as you can imagine. But then came the bright idea that we can go online even with the exhibition, and we thought of this idea of asking students to work on things which they find around themselves in their house, in their surrounding, and think of how these things work. And actually, I must say the students' imagination really went beyond the boundaries that we had thought of, and so many exhibit videos from so many varied topics, which are all strictly within the reach of a person who is stuck in the house under the lockdown. It really came out, and as a result, we have this exhibition online. And in fact, as is the case with any situation that life brings to us, there are a few advantages to this exhibition being online, which we would have never got with a physical exhibition that we used to have till last year. The first and foremost is we used to get college hall just for one day to show the exhibition. Now the exhibition is on, and it will remain on even after this valedictory function is over. So that was the largest advantage, I must say. We could invite a guest from all the way from Ratnagiri to come and judge our exhibition. And now we are holding a valedictory function, sitting at home, everyone is enjoying attending it. And I hope that this online mode and offline mode of actual physical interaction is what we will continue in the years to come, and enjoy both benefits of both modes of operation. So with this, I think I will ask Rajesh sir to proceed with the today's valedictory function further.
Thank you, ma'am. Thank you so much. Let me invite Professor Mistry. Professor Mistry has been one of the judges, so we would like to have his perspective on the exhibition and his words for the finalists and other participants. I think he has gone through most of the videos, even those who could not reach to finals, and he should be able to guide you in a better way. Sir, please.
Yeah, thank you, Rajesh. Is it possible to see the students in gallery view, like in Zoom?
Uh,
Is there some
it should be possible.
screen?
It should be possible.
Yeah.
It should be possible. Just that the system runs little slow. But let me try. Uh,
I think, Mistry sir, you will have to do the setting in your Meet. There are those three dots on the right side. If you click on that, you change layout. Go to that change layout in the menu there, and then you will see the.
yeah, because if I will do, you will not be able to see.
You will have to change that setting yourself. Go to change view in that menu which pops up from those three dots.
Yeah, I saw that. Okay.
And then so there is a grid view.
Layout, you go to this.
There is auto tile.
Yeah, select
tile. No.
Yeah, and at the bottom there is this whole thing which shows many more squares on the right side. take that middle bar all the way to the right so that it will allow you maximum some 49 people to see at a time. Yeah.
Yeah,
Okay,
yeah.
great. Yeah. Okay.
I don't know. Maximum, I think it is 9 or 25, no, depending on the.
No, 49 is
So
the
more
highest.
tiles. No. In one view.
49 can be
Anyway,
seen
I've
in one view. The button.
got something.
Yeah.
Yeah. But they are mostly off, the students, huh?
Yeah, the videos they keep off because if their
Only the.
internet connection is not very strong, then they like to keep it off.
Some should keep on, otherwise I can't have a reaction of what
Yeah.
I'm saying.
Yeah, please, those who can turn on the
I can
video.
see 3 of us only.
Yeah.
One per group at least.
Yeah.
12 groups. This is like hide and seek. Okay. Fine, I can see some of them. Huh? So, good evening, all of you. And thank you, Physics Department, for inviting me to see the virtual exhibition and also to evaluate the final selection of projects. First of all, I sincerely want to congratulate the department, all the teachers, for this program, even under the lockdown situation. Just now, Professor Jyoti explained to you how normal exhibitions take place in Xavier's all the time. But this is the first time they have attempted this virtual exhibition, which I find is not much different at all. Because we had all the possibility of looking at the experiments, talking to the students, looking at their results. So this is really something that I like, and especially when you realize that each of the 4 students in each group is separate, correct? Is from his or her own home. And yet you coordinated very, very well, including one of the groups which had the same type of blackboard and switched over the person, but in different geographical locations. So, and with limited facilities. After all, the physics facilities at home are quite limited, but still almost all of you all had something to show, something to demonstrate, something that worked. Okay? So for that, I don't know, in Zoom there is a clap. Can all of us do a clapping?
Yes, sir.
Rajesh, is there that? And
Please unmute yourself and clap.
So clap for all of you. Yeah.
Yeah. That's a good practice. We will need it while prize distribution.
Okay. Very quickly now. So just a few words on physics, because physics is all around us and physics is fun. You saw it. And this way, even in this pandemic where some of us do feel a little bit claustrophobic, not, many of us, I'm sure you also have not left your home for all these 5 to 7 months. Okay. And so for some of us senior citizens, in fact, it's prohibited. So, it's extremely difficult to be active in this type of thing. Yet, all of you had this fun, and that is really, really something which is very nice. So, for doing good, learning it and enjoying it, the important thing is to be curious. Okay? You must ask questions. Please remember that always. Ask questions and do not be satisfied by simple answers or what one can say, superficial explanation. Whether it's in the textbook, whether somebody said that, another person said that, you must go deeper and understand what is happening. You can ask 100 people, go on web, textbooks, whatever. But you should feel that, you've gone to the bottom of it as far as the known physics is. There's a lot of unknown which is still being researched, and that's the open question. So go into the details, how things really work. Don't be satisfied by just a few words in the textbook. Your exhibition had a variety of ordinary subjects at home covered, and you showed how physics works through at home and daily life. So for that, once again, you need not clap, but well done. Finally, a few words on presentation skills. Whenever I judge any exhibition, wherever, I normally tell the group itself, and you saw me when I was at each group, I already told you some things, okay? Some things to improve, some things which I like, some things which I didn't like, etc. So rather than tell just now, each of you know, and at least 2 or 3 groups, I actually, Jyoti, I actually told them to meet me after the lockdown if possible, to do a little bit of advancement of that project.
Yeah.
So if they are genuinely interested, I'll be very happy to meet them in college, okay?
Yes.
Apart from that, I'm talking of presentation skills. So apart from your content, the physics that you're doing, you must put it or present it well. And for that, it's the voice, it's the sound setting, because this is now technical. You are away. We are in a remote situation. So music is put in, yes. Many of you use good music also. Some of you use very good camera work. I was happy. But something was missing in some of you all when you explained. There was no joy or excitement in some groups. You all did it as a presentation. You understand what I'm saying? So if you're really excited by what you've done and you're happy, it's not the marks or the certificate or the grade, just the joy of something, achieving something, then that should come on your face. That type of excitement should come out from the way you present it. The next point is creativity. There were points for creativity in this evaluation sheet, and that's the toughest thing to do. You can do a normal presentation, you can do blackboard, you can do the slides, screening, actual demo, but what was creative? So some places, there was something which I really thought was done differently, which normally people would not strike. So that's the creativity. Also today, the tools are available. In fact, just now, today, I was telling them, I attended a seminar from 6 a.m. to 3 p.m. in Singapore. Okay, it's a world seminar. Actually, XIC people were there, 25 people also. But it's so easy to talk to people anywhere. So space and time and their times are totally different. You understand? That's why that's 6 a.m. for me. So people anywhere, anytime can come face to face like we are doing it now. We are in Bombay, but you could have been anywhere, Timbuktu maybe. Okay. So therefore, this new lockdown situation is not really different. As Professor Jyoti said, there are some benefits which normally you won't get in the physical situation. Okay? Your whole transport problem is not there. You are at home enjoying, and some are sleeping, I can see. No, sorry. Wait. One last thing is, avoid paraphernalia in front and behind you. See, we are at home, so every student spoke. You have to be a little careful about what's behind, what's in front, and the lighting. As you see each other, you will see some faces are in dark, some are in a mist or glow, some the contrast is there. So just be careful. In this situation, when you present from home, try to put other, props out of the way within the camera view, jo dikhta hai na, because people who are seeing you are also seeing outside the window behind you. You could see maybe the thing right behind the door or window. Okay. Last word is that remote online education is a challenge and is there to stay. I hope you know that UGC and all other universities everywhere have insisted that even after lockdown is removed, part of the syllabus will always be taught by online. And I can tell you, I can predict that not part, but more and more. I hope all of you know that even before pandemic, Coursera and MOOC and all these online studies were going on merrily. And you can learn skills online, not just physics, but whatever you want for your own growth. So it's a challenge and requires a change in our behavior, our thinking, and most of all, our innovation. Okay, so with these few words, best wishes, and thank you for inviting me. Thank you.
Thank you, sir.
I think
Okay, thank you.
I think we can unmute and clap. I mean, that's one thing we will keep missing.
Yeah.
And so whenever we wish to clap, maybe we can unmute ourselves and clap. The other judge, Professor Bhide, could not come to this meeting because he has a meeting in his college. So he said he may join late. If it's possible for him to join late, then we will ask him as well to give a feedback. So now we can go for the results. Yeah. So now we can go for the results. So I will first go for TY plus MSc results. The second place for TY plus MSc group is group 46, Dimag ki batti jalao, physics of fluorescent tube light. So you can give them a small clap. Before, that's right. And then please mute.
Rajesh, we can give you the certificate.
Please mute yourself. I receive it also. Please mute yourself after clapping. Before I request one of them to come and speak about their preparation and experience, let's have a look at their video once.
Yeah. Good idea, Rajesh sir, to show the video.
So this is just that.
Have you noticed how weird a tube light is? They seem to be everywhere, and we don't really notice that they are there. We just
Is the sound
push a
not
button
there?
and the light comes on. However, there's a lot of physics behind how a tube light works. For being such simple
Sound is there. You can't hear?
No.
Where you are playing, it's on mute.
and plasma physics,
Now?
having such an interesting thing in your house and not noticing it, it's quite a thing. So if you look
No,
at a
sir.
tube light, it just looks like a tube.
Just hold
which
on.
has like these connectors on.
Go to the link in the drive and
Ma'am, please hold
which
on.
has this weird thing over
Yeah.
here. We'll go
Before
ahead.
he breaks the tube, quick.
Go back and play.
Actually, your presentation is on mute.
The AC supply is connected in series with a ballast, which is an inductor, which is connected to the tube through a starter switch, which works as a gas discharge lamp. Now, when the voltage enters through the ballast, it first gets filtered through the capacitors and then the
So you can try sharing the Chrome tab instead. It's better optimized for video and animations.
Yeah, just a minute.
राजेश वो ब्रेकिंग द ट्यूब से दिखाओ.
Ionization. For any gas at a given pressure and temperature, there exists a voltage value called the breakdown potential that will produce ionization. Application of voltage above
have you
this
joined
critical
using two
value
devices?
would initially cause the current to increase due to cumulative ionization. This creates
All of
a
you
path
please
of low
maintain
resistance
silence. This is
called
going
R,
live, so
which decreases the voltage.
live voice is
Hence,
going.
in
Check on your
fluorescent
mobile
tubes,
phones.
once the voltage between
I would recommend please check on your mobile phones. The voice is there.
And how it works. And of course, if you have to explain how a tube light works, you need to get inside the tube light. How do you get inside a tube light? Well, Well, that was anticlimactic. Definitely needs more drama. Well, that's more.
Kick up a high voltage that starts the lamp. Once the voltage is high enough, the filaments of the bimetallic switch get heated up and short together, thereby charging up the filaments of the tube. This is repeated till the voltage is high enough to
exceeds the breakdown
Rajesh, we can
potential.
close
The gas
all our video and go back to the
becomes
previous view.
self-sufficient.
I think it's
And very low voltage
requiring
is sufficient
more
to maintain the
data.
required current.
The basic idea of fluorescence spectrum.
And that, in summary, is how
During the screening, we can shut off the video, audio both.
So the high voltage that is needed is provided by a ballast that kickstarts the ionization.
This high voltage ionizes the gas and creates a plasma which enables current regulation even at low voltage.
The ions give off UV radiations which are absorbed by the phosphor coating, which transition to the ground state and emit the visible light. The transition of electron for this emission of light is because of fluorescence.
Electronics, plasma physics, and quantum mechanics working together make a tube light work. That's the physics of tube lights. Bye-bye.
मेरा ही ट्यूबलाइट था वो. मैं सोचा क्या कर सकते हैं, मैं बच्चे लोग को दे देता हूँ, थोड़े थोड़ा कुछ करें.
ओके सो बच्चे लोगों ने कुछ कमाल किया है. कैन यू ऑल हियर मी?
Yes.
Yeah, there is some issue with when I'm sharing the mobile via the YouTube video.
Welcome, ladies and gentlemen.
But
so today I'm going to show you the physics principle.
So you can share straight from
Remember,
the link that you have got from them instead of showing it via the YouTube
what
channel.
are the
Then
physics
it
principles
comes
that
with the
surround
sound and boom.
Well, let's just first
That's
start
my
with this
experience
step.
when I was
Now this stud is not breaking because my weight is getting divided along.
No, wait. No, I'm not. Please mind that if it played nicely on my screen and I could hear the sound. Since I could hear the sound, it has gone online with sound. So in YouTube live streaming, it has gone with sound. So please don't worry about it. You all could not hear because there must be some technical reason. So let's go ahead. I will invite at least one of these four. These four are Neil, Shreyasi, Shashwati and Emma. So if one of them can join here, this is their certificate. If this is their certificate, which they will get soon after the event gets over. If one of them can join here, who is joining?
I think I'll explain.
Neil? Yeah.
Yeah.
Can you quickly go through your experience of preparing this video and making it?
So the original inspiration came from, so all of us were thinking about picking something which is so mundane that we don't notice it, but has incredible and interesting physics involved in it. And after like talking for like a couple of hours, we settled on the tube light. Everyone was kind of nervous about how we can make the tube light interesting. But then as we read more into it and as we read how it involves a bunch of plasma physics and how it involves a lot of atomic and molecular physics, which requires fair understanding of quantum mechanics, we felt like inspired to continue on with it. And then we planned out like a storyboard of what we can do. We were like super busy with our schedules. We had like a lot of deadlines and we had to get the whole thing done in like about a day. So the whole thing was shot, edited and uploaded to Rajesh's Google Drive within 24 hours. And we even did the editing on the fly within those 24 hours. So it was a lot of fun, especially because we specifically got like a break from regular studies. We got to interact with our friends in a different environment other than the classroom. And it felt, it had that little essence of Jigyasa from last year, where the department gets together and gets to interact with everyone. It was nice. It was fun.
Okay. And how about that cameo? You asked somebody to do a cameo role in the end?
Yeah, so Navneet stays near my place. So we thought we could like He helped us out with some of the shootings. And Navneet being Navneet, he's like ever the stand-up comedian, and he cracked a few jokes. He got it on tape and just put it in the video. That's all.
Okay, great. Thank you, Neil. You can stop sharing your screen. Oh, okay. You're not sharing, in fact. So you can mute yourself. So let's go ahead. Now we go to the first prize for the TY plus MSc group. The first prize goes to group number 37. So if you can give them a clap. The title is Why Bubbles Are So Darn Colorful. And the team name is Dipanshu, Hetanshu, Avalon, Bijin. So your certificates are also ready here. And you will receive it immediately after the event gets over. Let me play the video here. Even if you can't hear the sound, please bear with me. For the live feed, the sound will play nicely.
Well, what makes a bubble a bubble? It's both as a wave and a particle. Let's just focus on the wave nature for this one. Just like any other wave, light follows the principle of superposition. It is this property of light that results into the phenomena of interference and diffraction. These phenomena also serve as proof of the wave nature of light. Interference here is what we want to dive deeper into so as to understand how the interference happens in a bubble, which results into the colors that we see.
Let us look into how this phenomena takes place in a bubble. Before that, the phenomena of observing different colors on a bubble is called iridescence. The main reason for iridescence is interference. But when we performed the double slit experiment, we did not see any colors. The reason for that is we use light also partially goes through the film, and at the second layer it again gets partially reflected. The second thickness determines whether light, a particular wavelength, gets amplified or cancelled out. And since this thickness varies all over the bubble, we get different colors.
So this was a video for them which we played. I would invite one of these participants to come and speak a few words about their experience.
Yes, sir.
Who is this?
Can you? Hello.
Can you put your video on?
Sir, actually, my laptop does not have a webcam, and my external webcam
Okay,
is
no issues. Go ahead.
So basically, we're thinking of topics that we could come up with for the project, and there was a lot around us, but we were thinking of something that was not so not so obvious when it comes to the physics that surrounds us every day. And you're thinking of something along the lines of physics that is easier to explain when it comes to how intuitive it can get. And optics was the best option for that, and that's why we chose the topic of bubbles and the colors around them. Now, the problem with this was that none of us were around, and all of us had to figure out ways to interact with each other through an online medium. And that's where our first challenge was. So my first idea was to have one of my friends speak in front of a green screen so that I could edit him out of the frame and put him into the video. But we could not find green screens that were being delivered within the time that we required. So we had to think of different alternatives. Now, this was really helped by the script that my friends wrote. And when we came up with this idea of having this editor's board, wherein we could have animations that I came up with, aiding the presentation that was going on side by side. Now, this was like a way of having some visual reference to look at while the physics is being explained, and that goes a long way in explaining and understanding the phenomena that takes place. So, spent 3 nights animating all of it, but I guess in the end it was worth it. And my friends and everyone who really were supportive to all of this, getting me videos on time, sending them to me in compressed sizes and everything, and making sure that the recording was crisp, clear, and to the point. It would not have been like possible if it weren't for these guys. And the coordination that I've come to expect from my friends goes a long way in making this a team effort. And I'm really glad of how it all has turned out towards the end. It was an extremely intense learning curve for all of us. And here we are. Thank you.
Thank you, Etanshu. I think Professor Mistry have promised you to show you people the demo of colors on soap bubble.
No, I told them to try it themselves by just bending a wire and keeping the spread film and using some tinted cellophane paper for the making it semi-monochromatic and with white light.
Yeah.
You remember, you all have to do the black spot at top, which is the real physics.
Yes, sir. Avalon is on to
Yes, sir. I got that.
Oh, fine. Very good.
Okay, so let's go ahead. We will now go to the other section of
Rajesh,
yes, sir.
clap break here, Rajesh.
Clap. Let's clap. Yeah. Please mute yourself after clapping. Thank you. Let's go to the next section. Our next section was.
Sir, Father Keith has come.
Yeah. Welcome.
Father Keith has come.
Welcome, Father Keith.
Yeah, welcome, Father Keith. Father Keith himself is on mute, sir.
Yeah. So let's go ahead. If he stays there, then maybe we can ask him to. Hello, Father.
Hello.
Yeah.
I had another board of studies meeting, so let me not disturb your proceedings. I just wanted to wish you all well.
Yeah, we welcome you, and I will come back to you towards the end. We are halfway through. So in next 10 minutes, I think we will be finishing it, and then you can speak a few words after that.
Yeah, that will be very nice, Father Keith, if you can just wait for a few minutes.
Okay, sure.
Yeah.
Thank you. So, okay. So, kindly mute yourself. Let's go ahead. The other section of the exhibition was SYBSc students, and we had a large number of participants from SYBSc. So now I will declare the results for SYBSc. The second place goes to group 21, string theory. So if you can have a clap for them. The names are Panki, Kunika, Ria and Elvine. Here is your certificate. You will get it after the event. I will try to screen share the video, but do remember that if you don't get sound, please bear with it. Online, this is also going live, so sound will be available live. So this is group 21 for string theory.
Hello there. You all know what this is. Many of us know how to play it. But the real question is, do you know how it actually works? Like, why if I play A major, it sounds like A major, and G major, it sounds like G major. In order to understand that, we need some basics of acoustics and harmonics.
which it will naturally vibrate. Each of these frequencies is associated with a standing wave pattern, and the vibrations satisfy the relationship V is equals to n lambda. Standing waves. It is a combination of two waves moving in opposite directions, each with the same amplitude and frequency. The fundamental frequency, which is the lowest tone, is one where the wavelength of the wave on the string is twice the length of the string.
Speeds. The speed can be varied by either changing the tension or the mass density. So in terms of these two physical quantities, the fundamental frequency of an ideal string fixed at both ends is given by this equation over here. If we wanted to explain
Next time you hear any string instrument, just remember the string theory behind it.
So next time when you hear the string instrument, we can remember the string theory. And I remember the judging process started when Professor Bide asked these guys that, are you really going to talk about universe and related matters? So anyone from the group can come, can speak about their experience. Who is there coming? Alvin?
Yes, sir. Yes, sir.
Yeah, please
Good
go
evening.
ahead. Good evening. Please go ahead.
First of all, you were just discussing, I was discussing with our group, and the first thing what we thought of was to thank the physics department for giving us this platform for showcasing our exhibition. And because we thought that this year is just going to be a little bland and there won't be any touch to it the way we would have it in the lab. But this was, when we first saw the poster for an exhibition, we were all very excited because we are having a similar sort of what we would do on campus. Now we are doing it from home. So that was something really good from the department. And right from the time of starting forming the groups and deciding the topic, we went on with guitar and harmonics, because most of us, three of us in the group, were already musicians, and they were guitarists in our group. So we thought that would be something little interesting, especially when you go into music theory and applying physics to music theory. String theory came up for a catchy title because that is now very much in vogue. And I remember during the second Viva, Professor Vivek, he initially said that he was taken aback with the title, thinking it is actually talking about the string theory of the higher level and not the guitar part. So overall, it was quite a good experience. We with the part of recording the video, the slow-mo, especially the slow motion part of the string vibrating in those harmonics, and the PowerPoint presentation, basically the 4 slides that we showed was done by one of our group members, the explaining part. So it was actually a beautiful experience, very well enriching, and we look forward to more opportunities this year and the coming years. Thank you.
Thank you, Alvin. We will hope that we will have more opportunities, and we will work in more engaging manner for the remaining part of the semester. Thank you very much. If you can mute yourself now. Let's go to the first place. The first place in SYBSC section goes to group 5, Keep the Fire Burning. So let's give them a big round of applause. The names of the students are Palak, Shubhangi, Shivani and Murnal. The certificates are ready and you will get it soon after the event gets over. Now let me try to play their video here, just like we have played others.
This is lighting a matchstick. We all light matchsticks quite frequently, and I'm sure most of us have had that hypnotic moment observing the dance a flame does. What causes it to light? Which state does it exist in? Why is it yellow in color? And other numerous questions around it.
In the next 5 minutes, we'll be hovering around these questions and hopefully doing them some justice.
For First things first, there are three basic ingredients needed to burn anything. Fuel, the thing which will undergo oxidation, source of oxygen and energy, mostly in the form of heat. Friction here fulfills the job of providing energy. When a matchstick is rubbed against a rough surface, mainly a surface with a high coefficient of friction, such as matchbox, then friction between the head of the matchstick and the rough matchbox produces heat, or more precisely, the excess energy contained particles orbital producing free ions.
I would request all of you to please mute yourself.
Ma?
Yeah. Can we, I request all of you to please mute. Wait a minute. Yeah.
And what is a pool of free ions called? Plasma. Not so soon, but it highly depends on the temperature, the part of the flame, and the very definition of plasma to actually claim that. So, it definitely contains ions which do have electric charge. Next thing we want to focus on is its shape, specifically in the case of a candle flame. At the instant the chemical vaporized wax which hasn't yet burned up, because the combustion starts only when the wax meets the oxygen around the edge. Next thing we want to focus on is its shape, specifically in the case of a candle flame. At the instant the chemical reaction starts, gravity draws colder and denser air down to the base of the flame, displacing the hot air which rises. This convection process feeds oxygen to the fire, which burns up until the fuel runs out. The job of the wick is until the spherical blob of fuel is completely combusted. Since fire is a chain reaction, another very cool thing happens. Watch carefully. If you light the smoke of a candle, the flame lights up again. The soot you see coming out of the candle flame is actually ring structures made up of carbon. This is a product of partial oxidation reaction. The reaction isn't complete yet, means the soot particles you see still has the potential to burn further. Watch how the blue part traces the smoke down to the wick. Isn't it amazing? There's a lot that goes on indeed, but as a scientist once said, when it comes to fire, we have just started. And a lot of research has to be done in some of these areas. But for the elegance of the flame itself should be enough to fuel curiosity. So, thank you for watching this far and keep the fire burning.
So that was the presentation that top first group has presented. I invite one of them to speak about it. Who is coming?
Sir, me.
Shubhangi.
Can you hear me?
Yes,
Yeah.
yes, Shubhangi. Go ahead.
So, right off the bat, I would like to thank the entire physics department for organizing this event, which not only helped us dwell deep into the physics aspect of it, but into the technology part, into cooperation, teamwork, team spirit, and an endless list there. And I did watch all the videos, and I would like to say it must have been a very difficult job for the professors and the judges to pick out 1, 2, 3, or whichever, because efforts was clearly evident in all of those videos. And coming to our project specifically, we wanted to select something which is very simple according to as we think in the normal life, and but taking and talking about matchsticks or physics in flame in particular, we came across a lot of physics that goes on, and we had to cut short many parts of it and just stick to some parts of the physics aspects, because we had to put it in the stipulated time of 5 minutes, 5:30, that way. And it was a really difficult Herculean job to cut that short because everything was very, very interesting. And we personally learned a lot of things, that the flame inside is hollow, which I had never ever thought of. And I think a lot of professors and judges even told us that it was a new experience for them. And the video that we made was totally ours. Like, we did not put in anything that is outside except that one photo from NASA's experiment. All the clips that we saw and everything was our own this thing. So I mean, it was a really great thing, shooting all of that, getting it in slow motion, video editing, putting it all together. And you might have seen me, like me in the video and the audio part, but trust me, there is a lot that has been done behind the screen to get this here. And yeah, so that is what I would like to say. And it was a great team spirit, and we wouldn't have been able to do it and put this across without the all four of us coordinating, and of course the guidance of all the teachers and professors. So thank you everyone, and it really means a lot. We did
Thank
not
you.
think that we'll bag the first prize, so thank you.
Thank you, Shubhangi.
Rajesh,
Yes, sir.
can I just say 2 minutes?
Yes, of
Something
course.
on.
Of course,
Yeah.
of course.
When we judged all these, yes, they were very close. You see, the marks we have given is just 1 mark different generally between the first and second in both the categories.
Yes, in both the categories, just 1 mark
Very
difference was
close.
there.
Now, speaking to all the students who are present here, you saw this little demonstration on the candle. So the score of actually doing something which works and explaining the physics is what gets you the marks. Okay? So if you have time, please watch through all your colleagues' videos, whether you win or lose, and then realize that why did some get filtered in, selected, and from there, why did these two win and the other two win? Okay? And just now you saw a video which was done, of course, audio you didn't hear, but Aram said if you go through it, you will see the quality of these 4 videos that we have selected. Not only the quality, but the explanation and the full effort by the students. I really congratulate the department for getting this done. Thank you.
Thank you, Professor Mistry. We have one more category of announcement remaining, and that is the most popular video. I would very glad to tell you that the most popular video was the Jigyasa playlist. So the entire playlist was very popular. Uh, it has got around 30,000 views. Imagine 30,000 people roll their eyeballs on your videos, and it has got 450 hours of viewing time. Roughly around, it should be more than 450, around 450 hours of viewing time. It is much more, the views could be shorter, but the 450 hours of viewing time is the real hard proof that we have been able to reach to many more people than what we would have reached if we would have done this in an offline mode. So this is the effectivity of the medium. Uh, After Jigyasa playlist, the most popular video was group number 28, that is thermodynamics of AC. So clap to them also. They, of this total attention, 30,000 views and 450 hours of viewing, they drew around around 10% of this attention towards themselves, which was great. Now, so this was our list of announcement. I would
I
request.
just like to add, they will also get the certificate, only that is not ready. So in some
Yeah,
time
their
later.
certificate is not yet ready. They will get in some time. Remember, all the participants will get the certificate depending on your performance. It would be graded. Give us a couple of days and we will mail it to all of you. Now, I would request uh, Bijin from TYBSC to quickly give a general feedback about this entire event, what went well, what went wrong, what could still be improved. A student perspective. Please be quick, Bijin.
Yeah, so like I just have to mention that I have a very weak network connection, and so like if anything happens, I've told Hitanshu to fill me out, like fill for me. So I'll just start. So first of all, I'd like to congratulate the department for making this event a successful one. So now I'll get into feedbacks. I guess I'll start with the negatives first. One of the main issue that we faced was obviously being miles apart from each other, due to which we faced issues regarding proper communication. Another issue was recording things at home. This was a bit difficult because of the noise, distractions, and all. Then there was the fact that only a few number of people were good at editing videos, and even though in the fourth semester we had a semester-long lecture on video editing, it was still an issue. Next, I think the department has already looked into it, I guess. In the mark distribution, there were marks given to popularity. But even if a video is good, it need not have 500 plus views because it depends on contacts. But then Rajasa told that altogether we got like 30K views, so I guess it worked.
It worked. Bijin, the constraint to us was that as an exhibition, it should have reached to people.
Yeah.
Exhibition, idea of exhibition is that to show your work to people. So people who have seen somebody else's video have seen others' video also. So it worked to that extent. So if that's an issue, then that's an issue with everyone.
Yeah. Okay. All right. Okay. Now the positive. The first has to be the topic. Even though the topic was simple, it made us think. And unlike the previous exhibition topic, this year we had plenty of ideas to choose from, and it showed us that something which we see every day has lots of science behind it. Then the evaluations were carried out in a very systematic manner, and it was very useful for us. Like Ms. Trisa, like the assignments you gave us were pretty good, and like we have done it. And next is, since the lockdown has started, we lost the excitement and drama in life, and you'll probably know how important like drama is to save your life. So this exhibition brought a good change, and it helped us to socialize more, and we needed it. So that's it.
Thank you, Bijin. Thank you very much. Now, may I request Emma to give a feedback on the behalf of MSc students?
Yes, sir. Good evening, everyone. And I would like to take this chance to thank the department, first of all, for giving us this opportunity. And we as MSc, and since we were in a part 2 for us, at the beginning, it was a yes-no sort of a situation where we did not really know if we wanted to participate. I mean, we really wanted to be a part of it, but we were in such a big time crunch at that time with continuous assignments, deadlines, and project evaluations coming up. And we were in a state where we had to decide if ye karna hai ya nahi, and how much of time will we be able to invest in this and given to have like a proper quality video put up. And at the end, after a lot of talking, after a lot of discussion, not the entire class, but a few, most of us from our class decided to do this, and I'm really glad we did because everything else is already put out by everyone else that spoke before me. But the only problem that we faced was the time crunch, and I think I can say this on behalf of our entire MSc class, that if we had a little more time, maybe we could have been able to do a little more justice to the topics that we decided, because even if the concepts were really very basic, and even if the ideas were basic, that we saw them everywhere around us, when we looked into the physics of it, the concepts, they literally blew our minds even at the MSc level. So even when we were reading through stuff, and in the project that I did was of tube lights, fluorescent tube lights, and understanding the physics behind it, it really amazed us about how such fascinating things exist right between us, and they've been just there, and we've not been able to, take time out of our academics and appreciate the beauty of it. And so that is one really great thing that this exhibition let us do. And we would have appreciated it if we had like a little more time on that. Apart from that, the other thing was, as a feedback, it would be really nice if we could have like a pre-science communication session or something, wherein we can have like a professor giving us a talk on how we communicate the science that we understand. Because at times, like I think almost all of us went through this, that there was so much of content, and crunching all of that content into a 5-minute video, what should be added, what shouldn't be added, what is important, what is not important, what are the points that need to be covered, all of that becomes really very important when you're putting it out in such a small time frame. So if we had like a little more guidance on how to communicate the science that we're doing before we did it, I think that would really help the way we would be able to present our matter. So that is that. And yeah, I'm really glad that, so this is my last year in Xavier's, and my last physics exhibition. I've been doing this since I came to college in JC, and I was looking forward to working for this exhibition for one last time, and I'm really glad that the physics department gave us that opportunity and did not, just let it go because of the lockdown. And also, I'm really thankful that our college, our department is giving us that workspace, that space where we can interact with people and keep up the essence of physics through the different society. Like we have the Society of Physics and this Jigyasa that we just finished with. So all these are opportunities wherein we also keep up with our academics, and we also don't let go the joy and the satisfaction that physics brings us in everyday life. So yeah,
Thank you, Emma. We note down your points. Of course, time given to MSc students was a bit less, and you people had a very hectic schedule. So glad that at least majority of you joined this exhibition. And yes, undergraduate students do go with science communication sessions, but PG students don't. So maybe we can think about that. Uh, Now we go ahead. I would request Father Keith to have a few words of encouragement to our students. Father Keith, student, is a rector of our college, and he himself is a physics graduate. So, with those words, those introductory words, I would invite him. Father Keith.
Well, first, am I audible?
Yes, sir.
Yeah. First of all, I would like to congratulate the faculty for the leadership that you are showing in this, in encouraging students to forward, whatever field of study or research that they have invested time in. The theme that we have chosen this year is academic adaptability or flexibility. And I think the college as a whole, and here we can see the physics department in particular, has really responded well. And some of the points that have come up by the students, I'd like to congratulate the students for all your projects. I remember last year you all used the whole hall last year, students, and it was very interesting as well. And because the template has changed, but the students rose to the occasion and brought us. What I liked is not only were they able to conceive and to execute, but even to analyze the pros and cons and to graciously accept where they have stood also in terms of your ranking. These rankings are important, I suppose, for this formality. But what Emma said also, one or two points she said are important, is the commonplace things in life. Here is where you have an opportunity to also reveal to people certain aspects of it which are almost spiritual and mystical in nature. Physics is that discipline. We had very good teachers. Professor Jangu taught me also physics many years ago, more than 35 years ago. And sometimes we get lost in all the equations, all the assignments and the exams. But physics is one of those fields where you can really see the beauty of the created world. It is tremendously beautiful, and many aspects of it we are not aware of also. So the students have a tremendous future in the sense of revealing to people the beauty of that world, and as was brought out, to be able to reveal it in a way that people can understand. That means to be able to communicate, so that we don't get lost in all these the jargon, because every field will have its own jargon. So I'd like to encourage the students. Also, this, as was pointed out, I think Professor Rajesh also pointed out that this has given you tremendous opportunity to reach out to a much wider audience. when it's on campus, you have a certain select people, and those who know, those who like such programs will come, those who can travel. Here we have a chance to reach out internationally. So I'm hoping that even when college resumes normally, we are able to tap into this beautiful opportunity of the internet and reach out in a much wider manner. So I'd like to again uh, congratulate the staff, students, and all those who have come together to make this a success. All the best.
Thank you, Father Keith. That was really very encouraging words. Now I would request Professor Ajay to propose a vote of thanks for this event.
Yeah, so this is the last part where I'm supposed to give a vote of thanks. So I would like to extend my vote of thanks to the management of St. Xavier College, Father Keith, Principal Dr. Rajendra Sinde, to allow us to have the freedom to carry out this type of activity where we don't only check the student's ability only with the pen and paper, but we also enhance the skill like video editing, video making. So this kind of activities they are possible only because of the college has given us the freedom to carry out and to proceed in this direction. I would further like to extend my thanks to the external examiners, Dr. J.B. Mistry and Professor Bhide, for putting their time in evaluating top 12 videos and also giving them the needed and required feedback, which definitely our students will incorporate in their future projects, and they will come out with their better project next time. I would further like to give my thanks to convener of this exhibition Jigyasa 2020, Professor Rajesh Singh, who has created this idea. So why not to have exhibition online? And in the beginning, we opposed this activity because it was increasing the screen time. But he told us he gave us different ideas how to reduce the screen time, and finally we came out with certain parameters so that screen time will be reduced. So thanks a lot, Rajesh sir, for this activity to be possible in 2020. I also would like to
clap for Rajesh sir here.
Yeah.
Thank you all.
I would like to thank the faculties of the Department of Physics and all the students also who put in their lots of time in carrying out this online exhibition and finishing it successfully. Thanks a lot. Thanks everyone.
Thank you, Ajay sir.
Thank you, sir.
Yeah. Thank you very much. Jyoti ma'am, would you like to say something?
Yeah, I thought that I will let out a little secret out of the bag. Bijin said that, the popularity marks and it's unfair, those who can't reach out to a wider audience, those who don't have many contacts will get less marks and all that. So the secret is, we told you that there will be marks based on popularity because we wanted you all to spread the word and make a lot more people see the video, and also you will make it with more interest. But we don't want to be unfair to our students who can't have many more, people watching it or anything. So eventually we have given everybody all the 3 marks for popularity. So don't worry, nobody has been dealt with any unfair.
Yeah, the marks of the popularity marks has been given to everybody same.
Same, 3 marks. So I think students will be now very happy. No unfairness from physics faculty side.
Clap to the department.
Yeah. Okay. So with this we end this event, and I will stop the live feed. I would request faculty and including Professor Mistry to stay online. I mean to stay in the group. Students, you can leave this group now. Thank you very much. Thank you very much to everyone.
Yeah. Thank you, students.
Thank you.
Thank you so much. Thank you, sir. Thank you so much, ma'am.